All right, so we have a reaction problem here, precipitation reaction. Determine if a precipitation reaction occurs if aqueous solutions of lead 2 nitrate and sodium carbonate are mixed. If these two do form or precipitate, write the ionic, or really what I'm looking for, is the complete ionic equation and the net ionic equation. To do this, we have to mix the lead 2 nitrate and the sodium carbonate, and they tell us that they're aqueous solutions, so we already know that those are soluble. Lead, Pb, and it says the Roman numeral, so I know it's a +2. Nitrate is NO3 minus 1, and so I need 2 nitrates to balance out the lead, Aq, because I know it's aqueous, plus sodium carbonate. Carbonate's -2, the sodium is +1. I need 2 sodiums to balance out the carbonate, and that's aqueous. And then what we're going to do is determine what you get when these mix. Now this is a double displacement reaction, so the lead and the sodium are going to exchange places. So I'm going to put the lead with the carbonate. That's +2 and that's -2. So that's all right. And then the next thing I need is I need to put the sodium with the nitrate. Sodium is +1, the nitrate's -1, so that's okay. And then now that I've done this, I have to balance my equation. I have 2 sodiums here, but only 1 on the other side. So I'm going to put a 2 there. Come over here and look at nitrate. I already have 2 nitrates, so the equation is now balanced. The one thing I don't know is what goes in these spots here. So I look up on my solubility chart, and I recognize that sodium nitrate is soluble, so I'm going to write Aq, but lead carbonate does not fall out. Most carbonates are insoluble, and lead carbonate is not an exception. So this is going to drop out of solution, so I'm going to put a solid there. So this is a precipitation reaction. This equation right here is called the molecular equation. To take it to a complete ionic equation, I take anything that's aqueous and I break it apart. So lead 2 nitrate breaks apart to give the lead ion +2 aqueous plus 2 nitrate ions aqueous. So, and just doing those, don't forget to put the phases, don't forget to put the charges, both have to be there. Plus 2 sodium plus aqueous plus carbonate 2 minus aqueous. This is what's floating around in solution. Yields, now the carbonate, the lead carbonate doesn't break apart, so we're going to leave that together. It falls out of solution as lead carbonate, solid, plus 2 sodium ions aqueous plus 2 nitrate ions aqueous. So just looking at each one of these, lead, 2 nitrates, 2 sodiums, 1 carbonate, yielding lead carbonate, lead 2 carbonate, it doesn't break apart, 2 sodium ions, 2 nitrate ions. Don't forget to put the 2 sodiums and the 2 nitrates. All the charges, all the phases are included. This one here, the second equation, is the complete ionic equation. Now what we can do is look at this and identify the spectators. The spectator ions are ions that appear on both sides of the equation. So lead appears here, but it doesn't appear as an ion on this side. So lead is not a spectator. Nitrate is here, and it's also on that side. So that's a spectator, and we can cross out spectator ions. Sodium is here, as well as here, so I can cross that out. And then the carbonate appears in the lead 2 carbonate, so I can't cross that out. What remains is the net ionic equation. Pb2 plus aqueous bumps into and combines with carbonate ions in solution to yield lead 2 carbonate. So this last equation is the net ionic equation. Maggie, that's it.